Hi, in this video, I'm going to show you how to install R and RStudio. So first, R and RStudio are two separate packages, and you always need to install R first. And R is the basic package we are using, and RStudio is an integrated development environment, IDE for R. And RStudio is more user-friendly than using R directly, because it keeps track of your R script file, R console, plot, history, all in one place. And in this video, I'm going to show you how to install R and RStudio to both Windows and Mac OS systems. So first, we need to install R first, okay? And we need to go to this website, www.rproject.org. Okay, so for example, if I click this link, I'll be directed to this website. Then in this block, getting started, okay, click download R. Then you need to choose the Chrome mirror to download it from. Okay. So we generally recommend you to choose the one that is closest to you geographically. For example, I'm living in Pittsburgh, so I'm going to choose one from USA. Okay. The closest one is this one, StatLib, Carnegie Mellon University, Pittsburgh, PA. Okay. So I can just click this one. And then you should download R for your system, for your operating system. For example, if you are using Windows, you can click this one, download R for Windows. Okay. Click Base. Okay. Then click download R 4.2.2 for Windows. So this is the newest version for R, and click it. Then you will notice that there is an exe file downloading to your computer. Okay. Wait for a few seconds, and after it is done downloading, click it to execute it. Okay, execute the exe file. Okay. And when the dialog box opens, click Run. Then a setup wizard should appear. Okay, then keep clicking Next. Or if you want to make some change in different features, you can do so. Or you can always choose to use the default options. Okay, until it is finished. And then you should be able to see an icon on your desktop with a large capital R. So that is Windows system. How about Mac OS system? So go back to here, okay. Again, choose the closest site, and then choose download R from Mac OS. Okay. And then you need to choose the .pkg file that matches your version of the operating system. Okay. So you see there are different .pkg files. Okay, so most likely you will use this one, but pay close attention to the details of operating systems, okay, and find the one that matches to your system. Okay, and then download that package and click on the .pkg file once it has been downloaded fully, and follow the instructions on the screen. Okay, so that's all for downloading R. After we finish downloading R, we can install RStudio. Okay. To download RStudio, go to this website, okay, posit.co.downloads. We need to download RStudio for desktop. Okay, so click download RStudio. Okay. And then you see that on this page, there are two steps. The first step is to install R. Because you have already installed R, you can skip step 1, directly go to step 2. Okay. And then, if you are using Windows system, you can just directly click this one and then follow instructions. Okay, and if you're using Mac OS system, you can scroll down and find the system that matches to your system the most. Alright, that's all for this video. I hope this is helpful. Bye. Hi, in this video I'm going to talk about how to install our packages and how to uninstall, how to update and load our packages. Our packages are collections of functions and sometimes data sets and documentations that allow people to share with each other. R has many built-in packages already, but most times we need to install packages by ourselves. So let's see how to install packages first. There are 3 ways to do so. The first way is to use the install.packages function. For example, suppose we want to install a package called Survival. We can do the following. Type install.packages in the R console, followed by parentheses, and make sure that you put the package name in quotes. And click enter. And then you see that the package has been installed very quickly. Okay. And immediately you see in the packages panel, you can check that Survival is already installed. Okay, Survival is here, right? Then how to uninstall a package. Suppose I install a package and I think it is useless. So we can do the following. We can use the remove.packages function. Okay. So let me clear the console. And make sure that you put the package name in quotes too. Okay, remove.packages. Okay, pay attention, there is an S over here. Okay, and then you see the package has been removed. Okay. So since we only need to install packages once, we usually just type the code in R console instead of put it in R Markdown file or in R script. Okay. And the second way to install and remove package is using this packages panel directly. Okay. You see, if you click packages, highlight this tab, and then click install, then this window prompt up. Then you can type the package name here. For example, we still want to install this package, Survival. Okay. And then you can leave this as default and click install. And you see, after we click install, immediately install.packages code is shown in the R console. So which means these two are equivalent. Then check it. It has been installed here. Let's see, Survival is here. Okay. Then how to uninstall it from the panel? Just click it, check it, and then click this cross. Okay. And then R asks you, are you sure you wish to permanently uninstall the Survival package? Okay, click yes. And then the package has been removed from RStudio. And you might have noticed that when I click Survival, there is a line of code shown in the R console, which is library. Okay, which means when I check the box besides Survival, I actually load the package. Okay. So actually, library is used to load a package. Okay, we will talk about it in a moment. And yet the third way to install a package is to click this Tools button in the menu and then click Install Packages. And again, same window as we have seen earlier, we click Install. Okay, so we will omit this Okay. So 3 ways. Okay. So now after we install the package, we cannot use it yet. Whenever we open RStudio, we have to load the package so that we can use functions and datasets in the package. So how to load a package? For example, you see I have so many packages here. I suppose I want to load a package called tidyverse. Okay, tidyverse. I can do the following. Okay, you see when I use the library function, we don't have to use quote. So now you see the package has been loaded. And you see there are some notes here. Tidyverse is a package which includes a lot of different packages. One of them is dplyr, okay, dplyr package. And in it there is a function called filter. Okay. So this means that the filter function in tidyverse will mask the filter function in stats package. Okay. And the lag function will mask the lag function in stats package. Different packages may have same name functions. Okay. So it depends on the order of loading packages. The functions in the most recent package will mask functions in previously loaded packages. Okay, so pay attention to that. And you see, after I load tidyverse, some other packages have been checked too. Okay, you see string R, tibble, tidyr, okay, and some other things. Okay. So purrr, readr. That's because all of these packages are included in tidyverse. So whenever I load tidyverse, all of those packages are also available to us. So, and also you see that another way to load the package is to check the little box beside the package name. So for example, let me detach this package. So which means unload the package. Okay, detach those packages. Okay. And in particular, I just want to load the package called dplyr, dplyr. Over here, ggplot2 is also in tidyverse. Okay. So let me clear the console first. Okay. Suppose I just want to load dplyr, this package. Okay. Instead of using library function, the library function, I can just check it, okay, in RStudio. And now this package is available to us, okay, in our console. Okay. Alright, so we're done with install, uninstall, and load a package. Okay. And sometimes people use another function called require. Okay. So this function can also be used to load the package. For example, so this one, this also works. Okay. However, there is a very small bug about this require function. That is, if the package is actually not available to us. If we use the require function, it will not give you an error message. It will only give you a warning message, but the program will not be stopped. So imagine if you have a very long program, very long script, it's very easy to ignore this warning message because your program can still run. Unfortunately, you may use a wrong function from a wrong package because you actually hasn't loaded the correct package yet. Okay, so I don't recommend you to use the require function. Just always use the library function to load the package. Okay. Next one is update packages. We can use old.packages function to list all of the out-of-date packages. Okay, for example, if I type this one in my R console, you see I have so many packages that are out of date. But it is not necessary to always update all of the packages unless you really need to use the most recent version. So how to update a package? Two ways. One way is to use update.packages function, okay, and just leave it open, okay, update.packages parentheses, and then by doing so, RStudio will update all of the out-of-date packages for you. But each time it will ask you if you really want to update each package. Okay? If you don't want it to ask you each time, you can type ask equals false, okay, in it. In this case, RStudio will update all of the packages for you, okay, without asking. Another way is to use the packages panel. Okay, so click update, then a list of packages will be shown to you. You can choose the ones that you want to update. Okay, you don't have to update all of them. Okay, you can also select all of them, of course. Okay. Anyway, this is how to update a package or packages. And installing packages in regular R, okay, is similar. You can also use install.packages function, okay, or you can click packages and then click install packages, okay, and then you will have a list of packages to choose from. These are all of the available packages for R. Okay, you can choose one and install it. Alright, that's all for this video. I hope this is helpful. Thank you for watching. See you next time. Hi, welcome back to the R and RStudio Basics series. In this video, I'm going to talk about how to import data into R and RStudio. So this is an outline of today's video. First of all, we will talk about some base R functions, and then an R package, read R, which contains some very useful functions, and then some other packages available to us in R and RStudio. Then we will learn how to use the Importing Data tab in RStudio. And lastly, we will learn how to export data from R. So this is an outline of base R functions. Read.table function is the very, very basic function in base R. And it is very flexible. Actually, it can be used to import almost any type of data set. Okay, so this is the basic syntax. I only listed a few arguments, but actually there are many more arguments in read.table. And because it is too flexible, sometimes you have to specify those arguments specifically. So R provides some variants of read.table. In particular, these three are very commonly used. All right, let's see some examples. Suppose I want to import a data set with extension .txt, okay, a text file. And how to do it? The data set is stored here in this folder. Okay, it's called logging. Okay, it's a text file, okay, with white space as a separator. Before we start to import it, let's set the working directory. So that will help us to find the correct location. And from there, we know how to specify the directory correctly and also easily in a simple way. In RStudio, it's very easy to set the working directory. Okay, so for example, in this panel, then starting from the drive, I gradually find the folder I'm going to work with. And suppose I want to use this one as the working directory, I can just click this more. Okay, and then click this, set as working directory. Okay, then you see directly there is a line of code shown in our console. That means this is my current working directory. Okay, And starting from here, I can omit all of this when I specify a directory or a path. I can omit all of them, okay, starting from here. Suppose I want to import a data set, okay, from this folder, logging. So how to do it? Instead of typing the code in the R console directly, I created a script so that I can save the code for future usage. So this is a new R script I just created. So first, import data using base R functions. Okay, and the very first example is I want to import the logging data. Okay, logging using read.table function. Okay. So since my current working directory is here, I don't need to specify this whole thing anymore. I only need to type data / logging, okay, .txt. Okay. And then if you open the data set, you see that the first row actually contains the column names. Okay. So in this case, I need to specify header equals true. Okay. Because by default, read.table set header equals false. Okay. Then I can highlight it and run this line. Okay. You see it is available to us. Notice that after I use the read.table function to read in the data set and save it in logging, it seems that nothing happened. In order to view the data set, you have to type the name of it. Okay. So you see, okay. Or you can use the head function to show the first 6 rows by default, or for example, I just want to show 3 rows, okay, then just these 3 rows, right? Or I can use a function called str, show the structure of the data set. Okay, so this is a very good way to have an overview of a data set if the data set is very large. Okay, so this is the very first example. And we can also use read.table function to read in CSV files. Okay, for example, the Titanic data set, okay, is a CSV file. Okay, CSV file. We can do the following. Okay. So make sure you put everything, the path and the dataset name in quotes, okay, always. Okay. And then header equals true again. Okay. And this time you need to specify the separator, the delimiter. In this case, it is comma. Notice that for the first one, there's nothing happens because by default, the separator is space. And then we can, for example, also see a few rows of it. Okay, let me first clear the console, okay, and then run this line of code. Okay, so see, we have successfully imported the data set, Titanic, okay, and there are 7 variables. So this is CSV file. And so the separator is comma. Okay. And sometimes the separator is tab. In this case, we can also use read.table function. Okay. So for example, in my data folder, there is a data set called human. So this one is also a text document, but the delimiter is tab. Okay. In this case, let's read it again. Okay. Human read.table, okay, data human.txt, okay, and specify the separator. In this kind of time is tab. Okay, we use /t to denote tab, and again header equals true. Okay, and then we can see the structure of it or the first few rows. Okay. We can also use the view function in RStudio the view function will show you the entire data set in spreadsheet form. Okay, so let's see this one. If I run this, okay, you see immediately in this panel, a spreadsheet will be shown for you. The entire data set will be illustrated here. Okay, so it is very convenient too. All right, so this is how to use read.table function. And for CSV files, of course, we can use the read.csv function. Okay, as I said, read.csv is a variant for read.table. It is used for CSV files in particular. Okay, so that you don't need to specify a lot of arguments anymore. So there are some default values for CSV files. So let's see how to read the Titanic dataset using read.csv. Okay. So now let's give it a new name, Titanic 2. Okay. Okay. So now you see, since there is a header, okay, the first row contains column names, and by default, for read.csv, header equals true, okay, and the separator is comma. Okay, so you don't need to specify these two arguments anymore. If you use read.csv, we can now let's use structure function. Okay, to see the structure of it. Okay, let me clean this part and run these two rows. So we successfully imported Titanic using read.csv, and you see there are some basic information about Titanic 2, okay, printed out in the R console. Okay, 1313 observations, 7 variables, and for each variable, the type of the variable and the first few values of that column are shown in the R console. Okay, so read.csv. And then human is a tab delimited data set, right? In R, we can also use a read.delim function to read tab separated data set. Okay, so let's try this, okay, for human again. Okay, remember human is tab separated. Okay, let's see human 2. Okay, create a new data set called human 2. Read.delim, okay, and specify the data set. Okay. Then nothing else is needed. Okay. So let's see, only show the first 2 rows of it. Okay. I run it. Okay. So if the dataset is tab delimited and we use the read.delim function, then we don't need to specify any other arguments. Okay, so we can omit these 2 arguments. Alright, so that's all for importing data using base R functions. So see all of these functions. And there is a package called readr, and it is a very good package which contains some very efficient functions that we can use to import data. So they are kind of parallel to those functions in base R. Okay, so for example, read_csv is used to read in comma separated files, and read_tsv is for tab separated data, and read_delim is used to import delimiters that are different from comma and tab. Okay, some other special cases. Okay, and some other things. Okay, so let's use this package now. Okay. Okay, so let's first try read_csv. Okay, Titanic is a CSV file, right? So let's do the following. And first we need to load the package. Okay, readr. And then let's use the function in readr. Okay, so still Titanic. Now I call it Titanic 3. Okay. _CSV. Okay, so in base R it's called read.csv. In readr package it's called read_csv. And then again, the first argument is the file, okay, the directory to the file. Okay, Okay, so we can still say data/titanic.csv. Okay, and then we're done. Okay, make sure you highlight this too. Okay, we need to run this loading package line too. Okay, so see, and remember there is a read underscore tsv function, which is used to import tab sub files. Okay, remember, human is tab separated. Okay. TSV. Okay. And then we're done. Okay. Let's view it again. Okay. In RStudio. So see, the data set has been imported, okay, correctly. You can also, for example, see the structure of it. The structure of it is pretty simple. So the delimiter is tab, okay, and structure is, it has two variables, okay, both numeric, and it listed a few values for each variable. And we can also use read underscore delim function to read in tab delimited data set. Let's try it. Yeah, but for this function, you need to specify the delimiter. And make sure that you use the delim argument. Okay, so in read R, the argument that we use to specify the delimiter is delim argument, okay, not SEP anymore. Okay. So let's see. Okay, so it's correct. All right, that's all for read R package. And certainly there are some other functions available for us, but we don't have to exercise all of them. You can try them by yourselves. Why do we need to use read R functions instead of base R functions? So compared to the corresponding base functions, read R functions are generally much faster, okay? Up to 10 to 100 times faster than base R function, depending on the data set. And also, read R functions leave strings as it by default and automatically parse common date time formats. And also, read R functions have a very helpful progress bar if loading is going to take a while. All right, let's move on. So notice that we haven't talked about how to import Excel files yet. So it turns out that we cannot use base R functions or functions in read R to read in Excel files directly. Okay. So there are two packages, read XL or XLSX. Okay, so they are quite similar in terms of syntax. So we will now skip it because we can also import Excel files from the importing data set tab in RStudio directly. And then we can see how the code looks like. We can also read SAS datasets into R. Okay. So since I haven't used this function yet, I will not show you an example for this case. But later on, I may create a separate video about reading SAS dataset into R. Okay. Now, next one, importing dataset tab in RStudio. Okay. It's actually pretty convenient to do so if you are a beginner. Let's see how to do it. So this is the environment tab. Okay, environment tab. It shows you the data sets that have been loaded already. Okay, so let me first clear all of these, okay, to make it clear. Okay, so notice that there is an import data set button here. So you can use it to import different types of data using different functions. For example, from text data, you can use base R functions or read R package functions. And also you can read in Excel files. Okay. So for example, let me use read R function to read in logging, okay, logging data set. Okay. And pay attention, there are a few things you need to modify probably. Okay. For example, by default, the delimiter is comma, but we know that the logging data set has a different delimiter. Okay. It should be white space. And after you change it, RStudio automatically reload the data. Okay, so now this is the correct way, okay, which is good. Okay, and now we're done. Okay, and instead of click import button, we can actually copy the code by clicking here, copy the code, okay, and click cancel, and then paste it here. Okay, paste it here. Okay. So usually I recommend you to save your code in an R script. Okay. If you just directly click import, then the code will be run and it will be shown in R console, but the code will not be saved. Okay. So I suggest you to copy the code and save it here. Okay. But still, this is not run yet. Okay. You need to run it to see. Okay, so automatically it will view the data. You certainly can use head or str function too. Okay, so this is how to read in a data set using import data set tab. Okay, and similarly you can read in, for example, as CSV file. Okay, Titanic, right? Click open. And since the delimiter is comma, okay, the data has been read in correctly, okay, in the correct form. However, notice that some categorical variables are character variables, coded as characters. For example, passenger class and sex. Home destination is character, that's fine. Okay, and embarked is a character too. Okay. So suppose I want to change the type of column. I can just click this arrow and then change the type I want. Usually for this kind of categorical variable, I want to use a factor variable. And then I'll ask you to list the levels of that factor. Okay, so unique values for that factor. And since I'm pretty familiar with this data set, I can just directly list it. So first, second, and third. Okay, there are 3 classes in the Titanic data set. And click OK. And you see this column is a factor variable now. Okay, similarly for sex. Also a factor, okay. Female, male, and then it's a factor, okay. And also survival, okay. Same thing. Yes or no, okay. 2 levels, okay. Notice that it's a comma separated list of factors. Okay. All right, so again, instead of click this import button, I will copy the code, okay, and cancel, and then paste the code here, so that all of the code that I used will be pasted here. Okay. Of course, you probably need to add it a little bit because it looks very weird, okay, by default. Okay. Basically, there are too many unnecessary space by default. Okay. And yeah, and by default it will view the data set. Okay, we definitely don't have to do it, okay, because the Titanic is a quite large data set. We can just see a few lines of it. Okay, and then just run it. Okay. Yeah, by default it will load the package again, but definitely we don't need to actually. Okay, we have loaded already in the script. Okay. All right. Then remember Excel. Okay, we haven't talked about how to import Excel files yet. Okay. So let's see. The students is an Excel file which has 2 sheets, right? And automatically it will by default import the first sheet. Okay, info1. Okay, so this is a default info1. Okay. And you see that you can actually specify the range of cells that contain the data. Okay, but for this one we don't have to, because there is no metadata in front of it or below the data values. However, there is a asterisk here. Okay, so this one is used to denote missing value, but we probably want to use the R notation for missing value. So you can specify here so that when R import the sheets, okay, it will automatically change asterisk to an A for you. Okay, so you see after I type this one, automatically there is a argument specified in the code. Okay, so NA equals asterisk. Okay, and we can get rid of this view. Oh, we don't. Okay, not sorry. So copy it. Okay, and cancel. Then we can. So now we are actually importing. Okay, so you see, by default, RStudio uses this package, readXL, and the function that is used is read_XL. Okay, and this is the data. This is the sheets. Okay, so we chose the first one, and then the missing value is asterisk. Okay, and let's see. Oh, by the way, let's give a sheet name, okay, so that we will not be confused. Okay, so run all of these, and yes, the data set has been imported correctly. Okay, so now what about the second sheet in students? Suppose I want to import a second sheet. Then click browse and then find the data set, students. And then make sure you choose the second sheet, info2. And then you have 2 options. Remember, in the data set, there are 2 rows. The first row is academic performance. The second row is empty. Okay, you see, let's see, take a look at it again. Okay. You see, the first 2 rows are not data. Okay. So there are 2 options. Either use set skip equals 2. Okay, so skip 2 rows. Okay. Or you can specify the range of cells that contain the data. So from A3 to C8. Okay. And make sure before you import an Excel file, you close it. Okay. So let's see. So let's try to use the range. Okay, so A3 to D8. That D8? C8. Okay, C8. Okay. And then, so for now, let's just, yeah, it's correct. You see data preview is correct, right? And we can also do the following. So get rid of the range thing and skip equals 2. So immediately you see the code shows you here. Okay, skip equals 2. You also can import the data correctly in this way. Okay, and then you copy the code and cancel and save it here. Okay, and get rid of this. It's already done. And add the sheet title. Okay, the data set is very small, so we can directly view everything. Okay. So now it's imported correctly. And of course, you can change the column type to factor if you like. Okay, for example, ID or name. Okay. But for this one, it's not that necessary, okay, because they are not categorical variables, they are label variables. All right, that's how to use the Importing Dataset tab. It's very convenient for beginners. And just make sure that you save the code. And how to export data from R. In readR, there are two functions. write_CSV is used to write CSV file, and write_Excel and _CSV is used to write Excel file. So now let's see how to write a CSV file. Okay. So first, load the library. Of course, we have done so previously. We don't have to do it in this R script, but I just want to emphasize that the write_CSV function is in this package. Okay, so just directly call this function. Okay, then specify the data set you want to write. So for example, I just want to write students info 1. Okay, and then specify the path. Okay, the physical location that you want to write that CSV file in. Okay. So since my current working directory is here, I can omit the previous part of the directory. Okay, just starting from data first. I want to write it in this folder again. Okay. Okay, and then it's done. Okay, just run this code. Okay. It seems that nothing happened because the data set is just written in that folder. Let's check. Okay, so see students info is here. Oh, I forgot to add this. Okay, so let me write it again. Okay, so see students info.csv has been written here. Okay. Similarly, we can also write the second sheet. Okay, using so write this data set. So this one is the R object. Okay, we read in, and then this is the one that we will write. Okay, so let's do this and pay attention to this window when I click run. Okay, so we'll see this new data set has been created. Okay. Similarly, we can write an Excel file using write Excel CSV function. Okay. So let's see how to write Excel files. Okay. So let me slightly modify my code. So now let's do it. Let's add Excel here. Excel here. And then change the extension to okay. Change it to Excel. Okay. And then you see we have exported two Excel files. Okay. All right. So this is a recap of all of the functions we have talked about, and you can also search online to find more details about those functions. And these are references. I will put these links in the description of the video, so feel free to check them to see each article or ebook so you can see more information about importing data. Alright, thanks for watching. I hope this video is helpful for you. See you next time. Hello everyone, welcome back to the R and RStudio Basics series. In this video, I'm going to talk about how to create an R project. This is an outline of today's content. So what is an R project? An R project can be think of as a file or folder in your computer, or a storage area, or just a working directory. And what can be included in an R project? You can put R scripts in it and data sets that you will use in the project in that working directory. And also, when you generate some output from your code, you can save it in the project too. And later on, you will learn how to use R Markdown files to create reproducible reports. You can also put R Markdown files in an R project, and also the output of those R Markdown files. And of course, you will only put related things in a particular R project. Okay? And for other stuff, you should create a new R project. Okay. Then how to create an R project? Two ways in RStudio. So let's see how to create an R project in RStudio. Okay. It's very simple. The first way is to click this project tab here, okay, and then click New Project. And then it asks you whether or not you want to save the current working space image. I have nothing to save, so I just click Don't Save. And then RStudio starts to create a new project for me. Sometimes it takes a while. Alright, finally it's out. Okay. You can choose to create a new directory or existing directory, or even a version control repository. Okay, so now let's choose to create a new directory. And we will create a new project. So click this one. And then give a directory name or project name. For example, I want to create a project that contains all of the examples in Stat 1301. So I just call it Stat 1301 examples. Okay. And then create a project as subdirectory of. So you can choose the physical location of your project. So for now, this is where I really want to save the project, so I will leave it there. If you want to create it somewhere else, you can just click Browse and choose the location for that project. Okay. So I will just leave it like this and click Create Project. And you see automatically in this panel, in the Files tab, you see the R project I just created is here. Okay, so this is sort of like our current working directory. Okay, we can verify it by using this get wd. Okay, so indeed, okay, so the current working directory is the project I just created. Okay, so let me clean the R console. So this is how we create our project in RStudio, the first way. Very simple, right? Another way is to click File and then click New Project. And then you will get the same window that asks you to create a new directory or existing directory or a version control repository. Okay, see, same window. Okay, we can just cancel it because we already have the project. And then whenever we have the project, we probably want to create an R script and which contains some R code in it. So for example, let's create an R script. So click File and then New File and then R script. Let me give it a title. For example, Lecture 1 examples. Okay, and then I do some simple calculation. Okay, so x equals norm 10 and y equals e to the x, then plot x and y. Okay, and then I can run this code and see the plot is over here. Okay, and then we can save this R script. Okay, and when I save it, okay, I can choose where I want to save it, but by default it will be saved in the directory of my project. Okay, so I can call it lecture 1 example. Okay, save it. Click this files tab. You see that there is an R script created here, and we can also save the output in the same folder or in the same directory. For example, go back to plots. Okay, click the plots tab and then make it larger. It's a scatter plot. I can click export, and you can choose to export as an image. You have different choices like PNG, JPEG, etc. Okay, or you can choose to save it, export it as a PDF file, for example, as a PDF. Okay. And then you can choose the dimension in inches. For example, suppose I want to create a 5x5 PDF file. Okay. And then by default, you see the directory will be in the project. Okay. And give it a name. Okay, scatterplot1 and save. And then click files, you see the plot is saved here. Okay, all of them are in the same directory, in the same folder. Okay, stat 1301 examples. Okay, and we can also put data set here. For example, we can do the following. Okay, suppose I want to put this folder in the project. I can copy it and then go back to the physical location of my project, okay, which is here, and paste it here. And then you see in the files tab, you see the data set is already here. Okay. So one advantage of saving the data set in a project is it's very easy to read this data set. You don't need to specify a very long directory anymore. For example, I want to use the package readr to read in this CSV file. I can just call it life expectancy is read underscore CSV, okay, and then specify the file. Okay. Since this one is already in the folder and in the same folder of my R script, I just need to specify the name of the file without specifying the whole directory. So let me run this too. Okay, then you see it's already loaded. Okay. So before I put this data set in the project, I need to specify the entire directory, right? So this is very convenient too. So let me save this R script, okay, and then create an R markdown file. So click file and then new file, and then new R markdown, and choose a title, for example, lecture 1 examples, okay, same name, and then leave everything the same. And then suppose in this R markdown file, I just want to read in the data set and also create a plot. Okay. So I'll do the following, insert a chunk of code and then copy this whole thing here And then probably using the head function to take a look at the structure of the data set. This data set is about life expectancy of different countries in a few years. In particular, schooling is the average school years for people in the country. So we can create a scatter plot to show the relationship between schooling and GDP. So let's use the ggplot2 package. Okay, take the data set and then create a ggplot. So X is schooling. And Y should be GDP. Okay. And I want to create a very basic scatter plot. So I forgot to load the tidyverse package because the pipe operator is actually in the tidyverse package. Okay, so it looks that this plot is not very informatic. Okay, because the relationship is not linear, we can slightly modify the code because GDP is actually very right-skilled, and we it's better to take natural log, and then the relationship would be more linear. Okay, and then let's knit this file to for example HTML file, and then by default it will be saved here in the same project. So I can just call it lecture 1 EX again. So don't worry, because it has a different extension with the R code. You don't have any trouble of creating a file with that name. And also you see this is the report, okay, the output from the markdown file, okay, and automatically it is also saved in the same project. Okay, and notice that it also read the data without specifying the directory because the data set is in the same project. And another advantage of our project is you can actually move the entire project easily, okay, without losing any information. Okay, before we do that, let me close the project. Okay, close the project. How to close it? Click File and then click Close Project. And then R asks you if you want to save the workspace. Okay, click Don't Save. Okay. We don't need to save the results, which are saved in the workspace, because we saved our script and our markdown file. And lastly, let's see how to move an R project physically in your computer. For example, let's first find the project. Okay, if you don't know where it is, you can click this ... and then you can browse your computer. Okay, for example, I know my it is here, and then so this is the project. Okay, and then I can click this ... to move up a level, and then click this. I check this box by the project, and then click More. And then you are allowed to move it to somewhere else. For example, I want to click Move, and R asks you where you want to move it. For example, I want to move it to another folder, okay, which is R lecture slides, okay. And then click open, and then you see it's gone, okay. In the stat 1301 folder, the project is gone, but if I click R lecture slides, you see it is here, okay, and you open it, everything is here. And since in the code, for example, in the R script, when we read in dataset, we only specify the file name, okay, without any directory. Okay. Even if we move the entire project physically in the computer, we can still use the same code to read in the data without any trouble, okay, without any issue. Imagine if we specify the entire directory here. Okay? Of course, if you don't move the project, it's fine. But if you move the project to another folder, another directory, then you need to modify this directory accordingly. Otherwise, this will generate error. You cannot read in the data correctly. Okay. All right, that's all for today's video. I hope this is helpful. Thanks for watching. See you next time. Bye.